Assalamu alaikum, my name is Al-wazir, and today I'm here to present to you Milestone 4 and Subject Digital Systems. So basically, Milestone 4 is about finite state machine. This is the definition. You can read it in our report. So we had two ways, more and melee, and we split the work into two. Flores did the more.
So in Milestone 4, our group needs to build a basic finite state machine. A finite state machine is a computational model based on a fictional machine with one or more states. This machine can only have one active state at a time. It implies that the machine must transition from one state to another in order to carry out various tasks. When the right sequence of buttons is pressed, which our group sequence is DNND, a combination lock will run one round of the nitrider lights, adopting the same hardware arrangement as the nickel and dime vending machine, and the nitrider lights is the same as from Milestone 2. So this is the sketch of state diagram using Mohd approach. From state 0, if we got an input of D, it will go to state 1, and from state 1, if we got an input of N, it will go to state 2, and in state 2, if we got an input of N, it will go to state 3. And in state 3, if we got an input of D, it will go to state 4. And in state 4, if we got an input of D, it will go back to state 0. So from state 0 to state 4, the output is D, N, and D. In state 0, if we got an input of N, it will go back to state 0, and if we get an input of neither N or D, it will go back to state 0. And in state 1, if we got an input of D, it will go back to state 1, so it will continue the sequence of DNND, D, N, and D, and then done. And if we got neither D or N, it will also go back to state 1. In state 2, if we got an input of D, it will go back to state 1, and it will run the sequence of D, N, and D. And if we got neither D or N, it will go back to state 2. In state 3, if we got an input of N, it will go back to state 0, and it will return the sequence of D, N, and D. And if we got neither D or N, it will go back to state 3. And in state 4, if the input is neither done, it will go back to state 4. So this is the state diagram using Mohd approach in part 2. We got state 0, state 1, state 2, state 3, and state 4. So we compile this first. And then, so we can see the output waveform of the DNND. So here is the output of R. When the sequence is pressed DNND, the R and the state 4 will go high, and then it will go low again when the input 10 is pressed. And if the input is wrong, we have here D, 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 and N. It will not make the R output and state 4 output go high. And here we got D, N, and D, and it will go high again, the R and state 4, and then it will go low when the done input is pressed. After that, we make this to a symbol and we combine the more DNND state machine with the net riders. Here we got input filter, 2 input filters for the input D and N. This is the more DNND state machine, and this is our net riders from Milestone 2. After compilation successful with 0 errors, we can simulate the waveform, the output waveform of the final Mohd DNND. So here we got the input of D and ND, and it will trigger the net rider light switch is LED 1 until LED 6 to turn on with this right sequence. And then if we got, when we got wrong input, here we got NDDN, it will not turn up any lights, any LED. And when we move, when we press the right input again, which is DNND, it will trigger the LED lights or the net rider lights to turn on. After we simulate this and we got our desired output waveform, and the output waveform is already correct, we add a prescaler into the final diagram. Here we got prescaler. In this final diagram, we have only 1 clock instead of 2 clocks.
Mainly is, and to explain it more, basically it's 4 states. Each state need a specific input to go to the next state. Okay, so at the first one we have S0, can only go to S1 when D is 1 and N is 0. Okay, so we did all of this and we put it in a table so we can get the next state equation, which is here. Okay, we gathered all of the data using this diagram and put it here. As you can see here, we have an output. The output is only 1 at S3 and S4, which is here and here. So basically state 0 can only go to state 1 when D is 1, just like I said, and N is 0, as you can see. So the doctor taught us 2 ways. We can use K-map, which will take a lot of time, and we can use it using our minds, which will take way less time. So because it's a work, we did it in K-map just to be sure, but you can just take it the way you want. So basically using K-map, we got the next state equation, which basically is this. So the next state equation contains AND gates and OR gates and NOT gates. So basically we got these, and we got that R equal Q2 plus. So these are the outputs, Q0, this is Q0 plus, Q1, Q1 plus, Q2 plus, and because these are equal to each other, so we just put R. So we compiled, we can see here that when we press DNND, the R output will be high until TC comes high. As you can see here, when TC is 0, it keeps repeat at S4. So we have this long line. When it becomes positive, we reset. We go back to this 0 state. Okay, so it's self-explanatory. It's easy. You can read our report. Yeah. In here we put the input filter here, so we can press the buttons, and we took the first file and make it as a symbol, so we can connect these things to it. The input filter had the D and the N and 2 clocks. Each clock had a different input. So basically, we connected each one to its proper place, and as we can see here, the R, what's important in this project, is connected to the enable and the night rider. Okay, so we can display the LEDs 1, 1, 1. So we end up with this. Once the press DNND, we will get this LED 1 will be long, LED 2 will be shorter, till LED 6 will be shortest. Okay, will be all active and then we'll go down. Okay, so it's again self-explanatory. You can just see our report. In the end, last step, we put the prescaler and we put 2 clocks using 1 input. The first clock have 100 Hertz and connected to the clock and the input filter, and the second clock have 1 Hertz, so the night rider can be visible to the human eye. And this is the compilation, which is available in our report, and basically that's it. I hope you enjoyed this video, and I hope you can appreciate this work. Thank you. This is for other references, which will be available in the description.